Hey guys, I realized as I was looking through some things today that for the last mini project related to chi-square, there you may have some issues with some of the data sets. So I want to kind of address those in hopes that I can ward off um, some problems with the mini project, and I won't have to answer them 100 bazillion times. There are three types of chi-square test that we consider. And in all three cases, you are using qualitative data, which means you're using words or categories. Okay, so you need to be aware of that when you're selecting your variables. And I want to show you something in Minitab to kind of help you with that. In Minitab, within your data set, some of the columns you'll see labeled like C2-T or C6-T. Guys, that T stands for text, T-E-X-T. In other words, it has words in that column, which makes that column qualitative data. And Minitab is recognizing that it is qualitative data. Okay, so that's one way you can tell what variables are qualitative and what variables are not. For chi-square goodness of fit, you need to have a variable with at least three categories. Because if you have only two categories, like yes, no, or true, false, biological gender, male, female, then you would do a different kind of test. You would actually run what's called the two-mean t-test. So for chi-square goodness of fit, you need at least three categories. And you're looking to see, does that data fit or follow a known distribution? And I would encourage you, for our purposes, to basically consider that you have equal proportions, unless you want to do a lot of research and try to determine what these standardized proportions would be for that particular topic, which is really more work than I really want you to do. If you want to do the test of independence, you're going to use two different qualitative factors to see if they are independent or dependent, meaning they're related or not related. And oftentimes the data is presented or organized into a contingency table. But here again, for our purposes, you have the raw data, which actually changes the Minitab instructions. So I'm going to address that in just a minute. And then third is you have the test of homogeneity, and it's to check to see if two populations from unknown distributions have the same distribution as each other. So this is where you're either testing something like pre-test, post-test. You could do developing countries versus developed countries. And it doesn't matter, whether you have a certain number of categories. Probably the easiest of the three to do, if you're, kind of want to go the easy route, I would say is the goodness of fit, assuming you have a category that has at least three categories. So let me go out to Minitab for a minute. And I mentioned that you can tell C2-T is a text, but it is sex or the biological gender, so you only have two categories. So that won't work for chi-square goodness of fit. In this data set, the best option is going to be this THAL, thal, because I can see right off the bat that I have at least three categories because I see three different words. So here's where the process changes just a bit if you're doing chi-square goodness of fit, where you have the raw data. rather than having it summarized in a table. You would go Stat, Tables. We're doing chi-square goodness of fit. And instead of observed counts, you're going to use the option of categorical data. Okay, you're going to use the option of categorical data. And basically what's going to happen is Minitab will do the tallies behind the scenes. And again, I recommend that you do equal proportions and click OK. And you get the results. You get the table with your observed values as well as your expected. You get your chi-square value and the corresponding p-value, everything that you need when conducting that test. For the test of association, we would use two variables. Okay, go back again and let's review that. It says determine whether two qualitative factors are independent or dependent, and it doesn't specify that you have to have a certain number of categories. So what we might look here is maybe look at heart disease in relationship to male female, to the sex. So we could do stat, tables, chi-square test for association. And again, I need to tell it that I'm using the raw data. I'm going to make the rows the sex and the columns the heart disease. And then I can run the test. And again, Minitab behind the scenes does the table for me. Now this table does look a little wonky because next to female you have 72 and 25, and then below it you have what would be the expected. Okay, I don't really need that, but it's there. And then you can scroll on down and you're looking for the Pearson chi-squared value and the corresponding p-value. So that's test of association. That's not difficult if you have two qualitative variables. I could have done, gender and whether that was the fasting blood rate or whether they exercise. Okay, so again, you're just looking at the relationship between two variables, and the number of categories doesn't matter. Then you have the test for independence, and you're trying to see if two populations from unknown distributions have the same. I don't really have that example here because I need like either a before or after. And I don't have, I've got gender, that's not going to change, fasting blood rate, exercise, heart disease. So I don't really have two variables, like a before, after, pre-test, post-test. Maybe if we had their fasting blood. So I don't have what I need. So I can't do the test for homogeneity here, which is okay. Again, the easiest one in my mind is going to be to do the chi-square goodness of fit. But the biggest thing with chi-square goodness of fit, let me remind you, is tables, chi-square goodness of fit. You want to choose categorical data. Okay, because Minitab will do the summary for you so that you don't have to do it yourself. So I hope that'll help ward off some of the questions or problems that you may have associated with the chi-square mini project.